Okay, this is probability with cards. Standard deck of 52 cards. We're talking no jokers here, all right? And there's 4 suits: hearts, diamonds, clubs, spades. There's 13 cards in each suit. 2 of those suits are red. Okay, I just put pink. I didn't have red, but hearts are red, diamonds are red. So you end up with 13 plus 13, 26 red cards. It's 13 clubs, 13 spades. Those are both black suits. So 13 plus 13, 26 black cards. Every suit has 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king, ace. So there's 4 2s, 4 3s, 4 4s, etc. Also, the jacks, queens, and kings have pictures of people on them. They have faces on them, so those are called face cards. So there's 3 face cards in every suit. So that's a total of 12 face cards, 3 times 4. All right, first set of problems. If you draw 1 card from a standard deck of 52 cards, what are the following probabilities? What is the probability you would get the queen of clubs?
1%.
There's only, when you do probability, you take the number of ways you can succeed, you put that in the top, the numerator, over the total possibilities. So there's only one way to get the queen of clubs. That's if you pull the queen of clubs out of a total of 52 cards. So his first answer would be 1 out of 52. Any questions about that? All right, probability of getting a red card and a jack. Well, if you want to get a red card and you want it to be a jack, what are the 2 cards that you could get?
Jack of diamonds or jack of hearts?
Jack of diamonds or jack of hearts. So there's 2 ways to be successful out of 52 cards again. And so that would be your answer. Or I'd usually like you to reduce it, divide them both by 2, that's 1 over 26. Next one. You want to get a black card and you want it to be a face card. Remember, you're only drawing 1 card. So how many black face cards are there?
6.
If we're counting jacks, queens, kings as face cards.
Oh, aces.
I'm not counting aces. Maybe some people might. I'm not counting aces in this case. So there'd be jack, queen, king of clubs, jack, queen, king of spades. So 3 plus 3, 6 would be red. There'd be 6 black face cards out of 52 cards, which you could reduce to divide them by 2, 3 out of 26. These would both be correct answers. Any questions about that? All right. Probability of getting a 7 or a 9. Now, right, I'm going to give you a new vocab word here too. Being a 7 and being a 9 are called mutually exclusive events. They can't happen at the same time. You can't draw 1 card and have it be a 7 or a 9. So 7 or 9 are mutually exclusive, which means there's no overlap. All right? Probability of getting a 7 is 4 out of 52, plus the probability of getting a 9, 4 out of 52. Add those together, that's 8 out of 52. Those that you said 8 out of 52 are right. Of course, you can reduce. Divide them by 2, you'd get 4 out of 26. Divide by 2 out again, you'd get 2 out of 13, right? Being a red or a jack, those are not mutually exclusive events. Because you could draw 1 card and have it be both. There are some cards that are red and they're also jacks. Okay? So you got to be careful not to count those cards twice. So the way you do those problems is you take the probability of being red, which would be 26 out of 52, plus the probability of being a jack, which is 4 out of 52.
But then you have to subtract 2.
Right, you have to subtract 2 because the 2 red jacks got counted here and they got counted here. So you have to subtract those back out. So 26 plus 4 is 30, minus 2, that's 28 out of 52. Divide by 2, that's 14 out of 26, or 7 out of 13. Now, the other way to do that problem is just to count. Just to say, okay, I'm going to count up 13 cards, 13 diamonds, that's 26 cards. And then I'm going to count this jack, that's 27. And this jack, that's 28. So 28 out of 52. That might be easier. But when you have mutually exclusive events, you don't have to worry about doing that subtraction. But when you have events that are not mutually exclusive, where there's overlap, you have to think about that. Probability of being a black or a heart. Would those be mutually exclusive events?
Yeah.
Yes. There's no way a card can be both, a black and a heart. Okay? So we don't have to worry about any subtraction here. How many black cards are there? 26? Or means plus, by the way. If you notice, when I see or, I'm always adding my probabilities together. So 26 black cards, 13 hearts. So what's that add up to? 39 out of 52 chance. Which, divide them up by 3? 3/4 is correct. And you notice there's the same number of cards in each suit. This includes 2 suits plus another suit, so we're looking at 3 suits out of 4. All right, let's go to 2 cards now. If we draw 2 cards out of the deck, that's going to change things a little bit. If we draw 2 cards out from a standard deck of 52, what are the following probabilities? Now, if I say without replacement, that means I draw the first card out, I don't put it back in, and then I draw another card out. So I draw a card out, I keep it out, then I draw another card out. So I draw 2 cards out. So this time I have and. And means you're going to multiply my probabilities. And I have 2 different probabilities to have 2 cards. Over here, when there was and, I didn't have to multiply because I was only drawing 1 card. But over here, when I'm drawing 2 cards, this is going to mean and. So what's the probability of getting a king? You get 4 out of 52, which is also divided by 4, 1 out of 13. Okay? And means times. Now, without replacement means I've got a king out of the deck. So there's 1 king sitting over here somewhere. Now what's the probability of getting another king? 3 out of 51. There's 3 kings left out of the 51 cards that are left in the deck. Or another way, you could reduce 4 over 52 is 1/13 times 3 over 51, or 51. So you could take 1 times 3 would be 3. On the bottom, you take 13 times 51. Whatever you get would be your answer. How about a club? And a club. What's the probability of getting a club? It's 13 out of 52, or 1 suit out of 4. Each suit is equally likely. I'm going to write it like this. Let's do 13 out of 52. Without replacement means now I've got my club sitting off to the side. It's not in the deck. Now I go to draw my second card. What's the probability of getting another club? 12 out of 51. I could reduce the 13 out of 52 to 1/4. That's 12 over 51. I could do some cross canceling if I want, or just go straight across. 1 times 12 is 12. 4 times 51 is 204. And I could reduce, could divide them both by 4 and get like 3 over 51. That's my answer.
2, 4 divided by 12 is 17.
Oh, I could reduce again, couldn't I?
Yeah.
Divide them both by 3, that's 1 over 17. Thank you. So if in other words, if I drew 2 cards out of the deck 17 times, on average, only one of those times I would get 2 clubs. Again, if I draw 2 cards out of a deck, I do it 17 times, on average, I'd only get both clubs once. So if you're playing poker or something and you need to get 2 clubs, and you're thinking, oh, that's pretty likely, not very likely. Only 1 out of 17 chance. Okay? Now with replacement means you draw a card out of the deck, you look at it, put it back in, then you draw another card out. Okay? So the probability of getting a king, there's 4 kings in the deck out of 52. I put that card back in the deck, what's the probability of getting another king?
452.
It's still going to be 4 out of 52. So you take 4 times 4, 52 times 52, whatever that comes out to would be your probability. How about a red card? What's the probability of getting a red card? 26 out of 52.
Or just 2, 4.
Put the card back in the deck, this is with replacement. And then 26 out of 52 again,
2, 4. Yeah.
which 26 out of 52 reduces to a half. Same thing here. Half times half is 1/4. So 1 out of 4 chance I get two red cards if you draw 2 cards out of the deck.